We're doing a digital SAT math practice test. The subtopic is advanced math, and it's an advanced level test. So it's advanced math, and 13 questions. Let's see what we've got. The volume V of a sphere of radius r can be found with the given equation. Which of the following correctly shows the sphere's radius in terms of its volume? Okay, so we're being asked to solve for r. So how can we do that? Let me see what format are the answers in here. Actually, I think I have to turn the drawing off to see what is the format. Okay. All right, let's try it like this. Let me get the pen back. Why don't we start by dividing both sides by pi? We would get V over pi equals 4/3 r cubed. All right. Why don't we divide both sides by 4/3, which would really be multiplying by 3/4, and we're going to get 3 V over 4 pi equals r cubed. All right, now to solve for r, we've got to take the cube root of both sides. So we've got 3v over 4 pi, and we need a cube root of that. So let's see what we've got. So this one is 3v over 4 pi. Take the cube root, and that looks like the correct answer. A single processor takes 20 milliseconds to prepare data entries and 0.1 n milliseconds to copy the entries, where n is the number of entries. A multiprocessor takes 70 milliseconds to prepare and copy one data entry, and whenever the number of entries is doubled, the amount of time to prepare and copy them increases by 5 milliseconds. Given 120 milliseconds to prepare and copy data entries, which processor type can prepare and copy more entries, and how many more entries can it prepare and copy? All right, full disclosure, I had to look at the second part of this for a long time to work it into something that made sense to me. And so I'll tell you the way, I'll tell you the assumptions that I'm going to make about it. So a multiprocessor takes 70 milliseconds to give you one data entry. If you double the number of entries, the time increases by 5 milliseconds. But I couldn't figure out what that means. Does that mean like the second copy is going to take 75 milliseconds? Or are both of the two copies going to take 75 milliseconds? Or the first one is 70, the second one 75? I don't know. I think it would make more sense to say take 70 milliseconds to prepare and copy one data entry, and for each additional 5 milliseconds, you can double the number of entries that you can produce. So you've got 70 milliseconds, you'll get one copy. If you've got 75 milliseconds, you'll get 2 copies. If you've got 80 milliseconds, you'll get 4 copies, and so on, up to 120 milliseconds. But let's start with the first one, because that's the easier part. But the single processor takes 20 milliseconds. 20 milliseconds plus 0.1 n, and that is, it needs to be less than or equal to 120 milliseconds. All right. First of all, let's subtract 20 from both sides. We'll get 0.1 n less than or equal to 100, and then divide both sides by 0.1, and we're going to get n is less than or equal to 1,000. All right. Now, given the assumption that I'm going to make here on the second part, 70 milliseconds with the multiprocessor gets us one copy. All right. For every additional 5 milliseconds, we can double it. And we've got 50 milliseconds to work with. From 70 milliseconds to 120 milliseconds. So with 50 milliseconds, we can double it 10 times. So that's 2 to the 10th. 2 to the 10th. 2 to the 10th equals 1,024. I know that because I work with computers. So anyway, 24, we can get 24, the multiprocessor gives us 24 more copies. Got an option, multiprocessor, 24 more. There it is. What is the solution to the given equation? Square root of the polynomial equals 0. Okay, well, we could factor that. It's x minus 2 squared. So a solution would be 2. Functions f of x equals -2 times 1/3 to the x power, and g of x equals 2 times 1/3 to the x power. These are graphed in the xy plane. If AB, do they give a calculator for this? Yeah, I don't think we need it, but if g of x, if they're both graphed in the xy plane. If AB is a point on the graph of f, then which of the following is a point on the graph of G? Okay, well, if x is the same, then the y value is going to be the same, except it's going to be negative. So if AB is a point on the graph of f, then a negative b is going to be a point on the graph of G. Polynomial function f is defined as f of c equals c minus k times c squared minus 4c plus 4, where k is a constant. The value 2 is a 0 of f. What is the remainder of f of c when it's divided by c minus 2? Polynomial function f is defined as f of c equals c minus k times c squared minus 4c plus 4, where k is a constant. The value 2 is a 0 of f. What is the remainder of f of c when it's divided by c minus 2? Okay, so it's the remainder theorem. If you have a polynomial f of, usually we say like f of x, but okay, f of c, and you want to know what is the remainder if you divide it by c minus anything, in this case 2, you can get the remainder by just plugging 2 into the function. And we're already told that 2 is a 0 of the function. So that means that the remainder is going to be 0. Which of the following is equivalent to the given expression? Well, we want to group the like terms together. So like the v terms, we've got 3v minus 2/3 v. 3v is 9/3 v minus 2/3 v is 7/3 v. So A and B look plausible. I didn't mean to select A, but A and B look plausible. C and D do not look plausible. There's not going to be a v squared term in here. And then the rest of it, we need either 7/4 or 9/4. So we have 2 minus negative 1/4, which is like 2 plus 1/4, which is like 8/4 plus 1/4. Which would be like 9/4. So let's go with B. All right, which of the following is equivalent to the given expression 4x squared plus 28x plus 49? All right, well, I mean, let's not overthink this, okay? And any of these answers with 49 in there is wrong, because if you square 49, you're going to get a big number. Well, big, I mean, you're going to get a bigger number than 49. So we can't use B, and we can't use D. A and C we can use because we're going to square 7, and we're going to get 49. C, we're also going to square 4x. We're going to get 16x squared. So that's wrong. A, we're going to square 2x. We're going to get 4x. We're going to get 14x twice is 28x plus 49. And let's go with A. Okay, we have a couple of equations here. If x1, y1, and x2, y2 are distinct solutions to the system of equations shown, what is the product of x1 and x2? Okay, if we were going to solve this by hand, it would be pretty easy to knock the x term out of there, add the equations, factor, and get the solutions. But the show calculator, the digital SAT, they do give you a calculator. It's the same calculator that you would get here. And this is so easy to solve with the calculator that we are going to do the calculator. All right, move that over so we can see it. All right, first equation is a line. 2x plus 3y equals negative 8. 2x plus 3y equals negative 8. 2x plus 3y equals negative 8. All right, it's equation 1. Equation 2. Equation 2 was a parabola. 3y squared minus 8y is 2x plus 10. 3y squared minus 8y. 3y squared minus 8y equals 2x plus 10. Okay, so there's the two solutions. The first solution is negative 7. The second solution is, they want the x's, right? I have to go back and look at this again. X1, X2, yes, okay. Negative 7, negative 3.5. Right? Negative 7 times negative 3.5. 24.5. Okay, 4.5. Okay. All right. The graph of y equals f of x plus 2 is shown. For which value of x must f of x equal 4? All right, well, f of x plus 2 is a horizontal shift of f of x. Specifically, it is a shift of 2 units to the left. So the graph of f of x, it's the same graph, but 2 units to the right. So f of x, well, the value of the graph is 4 for f of x plus 2. The graph of f of x, that's when x is 0. So if we shift it 2 units to the right to get the graph of f of x, then the value of x has to be 2, and then f of x would be 4. Okay, what are the solutions to the given equation? Well, yeah, again, this is it's so easy to do it with the calculator. We do it with the calculator. It's not that hard to do it by hand either. If you multiply the whole thing through, I would multiply it by 2 to get rid of the fractions. So you'll get 4x squared minus 11x minus 3x. If you factor that, you get 4x plus 1 and x minus 3. I actually paused the recording and did the factoring, but so that tells us that the solutions are going to be negative 1/4 and 3. Is that an option? Negative 1/4 and 3. Yes, it's B. But I just, I wouldn't do that on the SAT. I mean, if they give you the calculator, and let's go back and look at this. What is the equation? 2x squared minus 11 halves x minus 3 halves. 2x squared minus 11 halves x minus 3 halves. I think I did something wrong there. Oh my God. Minus 11 halves x minus 3 halves. All right. It graphs it for you. All right, there it is. That's negative 1/4, and that is 3. Much easier. Okay. It's not that hard either way. It's not hard to once you multiply by 2, get rid of the fractions. It's not hard to factor it, but I still would go with the calculator. Anyway, the answer is going to be B. Okay. Let me scoot that back over. Two parabolas graphed in the xy plane have the equations y equals 2 times x minus 3 squared minus 7 and y equals negative x plus a squared plus 2, where a is a constant. For what value of a will the two parabolas have the same axis of symmetry? Two parabolas graphed in the xy plane have the equations y equals 2 times x minus 3 squared minus 7 and y equals negative x plus a squared plus 2, where a is a constant. For what value of a will the two parabolas have the same axis of symmetry? All right. And I think, did they show us a calculator on this? Okay, you can use a calculator. We'll do it, yeah, okay. If you were going to do this by hand, and actually I did it by hand, but you would put this into the form, a standard parabola equation. Just multiply it out. You get y equals ax squared plus bx plus c. And then for both equations, you can use the equation for the axis of symmetry, which is x equals negative b over, oh no, it's going to come flying out again, right? B over, I could have done it at that size too, I suppose. B over 2a. It's going to turn out that in order for this to work, the a constant in the equation is going to have to be -3. Oh, I can't do it that way. Okay, I'm going to stop, exit the drawing, but yeah, it works out to be -3. Again, it's easy to do this with the calculator that you're provided. So let's see what that looks like. Actually, let's do it like this. Show calculator. Give me a new calculator. All right. And the equations are 2x minus 3 squared minus 7. So 2x minus 3 squared minus 7, right? Minus 7. And the other one is negative x plus a squared plus 2. Negative x plus a. Now, when the Desmos calculator sees something besides x and y, it's going to ask you if you want to add a slider. In this case, we do want to add a slider. X minus a squared plus 2. Okay, it's actually a little bit too big. No, it's all right. It's all right. Now the slider, you can move the slider. You can see the axis of symmetry right now is not, they're not equal. But I already know what the answer is, so I can start sliding it in the right direction. 2.9, no, it's actually, it is actually going to be 3. And maybe it is a little bit too big to see it properly like that. But, yeah, so those have the same axis of symmetry now. -3. I mean, how do you know it's -3 and it's not like 2.9 or something like that? Well, actually, you can tell based on the answers that they provide here that none of the answers are really close together. So, yeah, axis of symmetry there, definitely you need a to equal -3. All right. Which of the following is equivalent? Let me scoot this over. Which of the following is equivalent to the expression for all c not equal to 0? Which of the following is equivalent to the given expression for all c not equal to 0? Okay, so without overthinking this, let's just look at the c's first. And say, what is the square root of c to the 20th? That would be c to the 10th. What's the square root of c to the 4th? it's c squared. So whatever happens in the rest of the equation, we're going to have c to the 10th over c squared. To do a quotient of powers like that, you just subtract the exponents. So we would need to have a c to the 8th somewhere here. Only one answer has a c to the 8th. As this one. I mean, let's double check the rest of it here. Square root of 8 is 2 to the square root of 2. Square root of 32 is 4 to the square root of 2, which is 1/2. So we're going to have 1/2 c to the 8th. All right. Which expression is equivalent to the given expression for all x less than 10? Okay, well, it looks like we need to factor it. So, factoring the numerator 12x minus x squared, we can just factor the x out and say that it equals x times 12 minus x. And that all goes over. All right, now how do we factor this? So factors of 24, 6 and 4, 6 and 4. I don't think that's going to, 6 and 4 is not going to, I don't think 6 and 4 is going to work. No, it's not going to work. 8 and 3, 12 and 2. 12 and 2 would work. So let's do this. X. Let me figure out the signs in a second here. 12. And we have x and 2. So we need negative. That needs to be negative. It needs to be positive. All right. So the 12 minus x. We have 12 minus x, and we've got x minus 12. Those are going to be the same number, but one of them is going to be negative. So what we can do is just cancel them out. We can cancel them out, but I mean, at 12 minus x over x minus 12 is negative 1. So we'll just put a negative in front of it. And so what we have now is, I didn't mean to write it that big, but okay, let's just do it anyway. Negative x over x plus 2. Negative x over x plus 2. Zoom it back. Back in. Negative x over x plus 2. Is that a possible answer? Negative x over x plus 2. Yes, there it is. Negative x over x plus 2. All right. Whoa. Well, that usually doesn't happen. Well, anyway, that's it. 13 out of 13. That is advanced math for the digital SAT. Hope you enjoyed it. Learned something. Feel free to like, comment, subscribe, and see you next time.